Hi everyone, I'm GM Godes, and now I'm going to discuss the linked list. What is linked list? A linked list is a linear data structure composed of individual elements, called nodes, that are linked together using pointers or references. Unlike arrays, linked list nodes are not stored in contiguous memory locations. Instead, each node contains its own data, and a link to the next node is the sequence. Concept of a linked list. Each node contains number 1, data, the actual value stored. Number 2, link or pointer. The address of the next node is the list. The list starts with a head node. The last node points to null, indicating the end of the list. So here's the simple example. Data, the value stored in the node. Next, a pointer that stores the address of the next node. Each box is one node. Arrow shows the link from one node to the next. The next pointer of the current node points to the next node, which is null, means no next node, indicates the end of the linked list. This is how it works. The first node is accessed using the head. Each node points to the next node. Traversal starts from the head and ends null. Types of linked list. Number one is singly linked list. The simplest form, where each node has only one pointer, pointing to the next node in the sequence. Traversal is possible in one direction only, forward. Data, the value stored in the node. Next, a pointer that points to the next node in the list. Example, if we have numbers 10, 20, 30 in a singly linked list, so we have head. The data is 10, then next, then arrow. Data is 20, next, then arrow, 30, then null. That means end. Here's an example of a singly linked list in C. stdio.h used for printf. stdilib.h used for malloc, dynamic memory allocation. A node structure defines a node of a linked list. Data stores the value. Next, pointer to the next node. Pointer declaration. Head points to the first node. Second, third, pointers to the next nodes. Initialize to null. Memory allocation. Malloc dynamically allocates memory for each node. Each pointer now points. In memory allocation, malloc dynamically allocates memory for each node. Each pointer now points to a valid node in memory. Assign data link. First node stores 1, points to the second node. Second, data is 2, points to the third node. Third node stores 3. Null means end of the linked list. Traversing the linked list. Current start at the head of the list. Loop continues until current becomes null. Prints the data of each node, moves to the next node using current or next. The output is 1, 2, and 3. The second type is doubly linked list. Each node contains an additional pointer to the previous node, allowing for bidirectional traversal, forward and background. Prev, a pointer to the previous node. Data, the value stored in the node. And next, a pointer to the next node. So here's the example. Doubly linked list, each node has 2 pointers. One to the next node. So we have data 10. Then, on 1, we have next node, and 1 to previous node. Can move forward and background. And easier deletion but more memory use. Here's the example. the data is 10, and we have arrow to prev, and we have arrow to the next. So, makamove siya to the next ni 20. And makamove siya to the next ni 30. Then, null. Then, forward na po siya. Ay, backward na po siya ni next. Then, ni 20. Then, next ni 10. Then, null. Here's an example of doubly linked list in C. stdio.h for print, stdilib.h for malloc dynamic memory allocation. Node structure defines a node of a linked list. This data stores the value, next stores the address of the next node. Pointer declarations. Head points to the first node. Second and third point to the next nodes. Initialize to null to avoid garbage values. In memory allocation, allocates memory for 3 nodes. Each pointer now refers to a valid node in memory. Assigning data and linking nodes. First node stores 1. First node stores 10. And second node stores 20. Third node stores 30. The null marks the end of the list. So head is 10, 20, 30, then null. Traversing the linked list, current start of the head prints the data of each node, moves to the next node using the next pointer. Stop when current become null. Next type is circular linked list. A circular linked list is a variation of a linked list where the last node points back to the head, forming a loop. This means there is no null at the end of the list. Circular linked lists can be either singly or doubly linked. They offer advantages such as assay traversal from any node and efficient implementation of algorithms that require looping. So, example, singly circular linked list. If we have numbers 10, 20, 30, the list looks like this. Head, the last node points back to the first node. No null at the end, efficient for continuous process. Used in quiz and round robin schedule. So, we have head, and then arrow, 10, then next 20, next 30, then next back to the head, then head 10, next 20, next arrow 30, then next. So, means no null at the end. And doubly circular linked list for numbers 10, 20, 30, head is 10. Point to the next to the 20 and next to 30 forward. Then frame next backward 30 back to 20 point to 10. And the common operations, basic operations performed on a linked list include insertion, adding a new node at the beginning, and or a specific positions within the list. Deletion, removing a specific node or a node at a given position from the list. Searching, finding a node that contains a specific data value requires traversal. Traversal, rotating through the list from the head to visit each node sequentially by following the pointers. And it's all. Thank you.